All right, here we have another problem featuring our world famous particle that moves along the x-axis that they love to work with all the time on these AP Calc tests. And so what are we being told about this world famous particle this time? This time we're being given that the acceleration of the particle is given by this equation here, a of t equals 30 square root of t. Then they're telling us the position of the particle is 5 when t equals 0. And then they're giving us more information about the position of the function. So the position of the particle is 10 when t equals 1. You'll notice, though, that they are actually asking us what is the velocity of the particle at t equals 0. So the question is not about position, the question is about velocity. Well, let's quickly make sure we're all on the same page when it comes to our physics relationship, so our physics stuff. So the physics stuff that they want us to know like the back of our hand for this AP Calc test is if I start with an initial function that is my position function, then the first derivative of position is equal to velocity. And then the second derivative of position, the first derivative of velocity, is equal to acceleration. And in the AP Calc test, you got to be able to kind of go both directions is what I say. You got to be able to drill down on this relationship and also go back up. When you're drilling down, that's when you're taking derivatives. When you need to move back up this system, that's when you're doing integrals. That's when you're finding antiderivatives. So this problem is starting us down here at the bottom with our acceleration equation. And it's wanting us to go back up and use the velocity equation to find an answer. However, it doesn't give us info specifically about the velocity equation. It gives us specific information about the position equation. And so what that's telling me is even though you might not be 100% sure why right now, but the odds are you're probably going to have to go back up twice, take the antiderivative twice to get back to that position function, and using that information to somehow find out your velocity function. Well, this is sort of going to be a take on what they refer to as an initial value problem. So what we do with initial value problems is we're usually given information to find those constants, right? When we take these antiderivatives, we always end up with a plus c. And if they give us some points to work from, we can then find out what that original plus c was. So this problem is giving us information, again, about the position function, right? So they're telling us the position at time 0 is 5. And then it's telling us the position at time 1 is 10. So we're probably going to be able to use that information to find out some c values that will hopefully end up giving us the velocity equation, which is what we really need to work from to get the answer out here. So we'll start at the bottom of our game and we're going to move up a level. So we're going to take the antiderivative of 30 square root of t dt. When you see a root in a problem, before you go rushing in to take the antiderivative, you want to remind yourself that there's a handful of algebraic rewrites you should be on the lookout for. And a root is the most common one. So whenever you've got x to some power inside a root, you want to rewrite that as a fraction. You want to rewrite that as x to the power divided by the root. So if you had something like the cube root of x to the 5th, you'd want to rewrite that as x to the power of 5 over the root of 3. So in our example here, we've got an unwritten 1 for our power and an unwritten 2 for our root. So the rewrite on this would be 30t to the power of 1 over the root of 2. So again, that's a rewrite only. We didn't take any antiderivatives yet. So now that we've done our rewrite, now we are ready to go through and take our antiderivative. And to do that, we're going to go ahead and apply the power rule for antiderivatives. It's a pretty straightforward integral to find using the power rule. So my power rule says add 1 to the power. And then step 2 of the process is divide by the new power. So following that rule, if I add 1 to the power here, I get 30t, adding 1 to 1/2 is going to get me 3/2 plus c, and then I divide by that new power. So I divide by that 3/2. So this now is my v of t. That's my velocity function. But I have no way of finding that plus c value that I would need to find in order to get the final answer here. So odds are I'm going to, again, like we talked about already, I'm probably going to have to go back to the position function and use those values there to help me find that c value. Before you rush into taking an antiderivative, again, look to clean up the problem as best you can. And one of the things we can do on this is I can use my division of fractions rule to rewrite this. So that would be 2/3 as I flip it, and then times 30t to the 3/2 plus c. From there, I can now go ahead and cancel a 3 and cancel a 3 out of there, making that a 10. So now my new v of t equation is going to be 2 times 10, which is 20t to the 3/2 plus c. So I'm now at level 2 here, and again, I need to take it back one more time, move it up the level one more time to get back to that original position function. So I'll take the antiderivative of 20t to the 3/2 plus c dt. And I'm going to follow my power rule again. So add 1 to the power. I get 20t, adding 1 to 3/2 gets me 5/2. Divide by that new power, 5/2, and then I get plus, and then what do I do about that c right there? Well, c is a constant. And remember, I always tell people, think about what you would do with a 5 in that situation. A 5 is a constant. If I had to take the antiderivative of 5, remember the antiderivatives of numbers by themselves just gain a letter back. So that would have been 5x plus c. So the same thing happens with this c. This would now become c, and then I gain a letter back, c times t. And then here, you still get a plus a constant. I'm not going to call it c again because that'll get confusing, so I'm just going to call it d. So this is now my original position function. And here again, before I go to use it, any further, I want to simplify it as best I can. So again, I'm going to go ahead and flip this bottom fraction. That's going to be 2/5 times 20t to the 5/2 plus ct plus d. And now, again, I can come in and I can sort of, I can cancel a 5 out of those. That would be a 4 on top. And so here I get 2 times 4 would get me 8t to the 5/2 plus ct plus d. And that is now going to equal my position function. So when I have this position function, now I can use these initial values over here to find what those missing constants are. The most important one, of course, being the c, because the c is what I need to finish out that velocity equation right there. So we'll start off. I always like to use the one with 0 first because it usually makes the math easier. So what this is saying is when I plug in t as 0, I want the answer to all of that math to equal 5. So plugging into my position function, I would say x of 0 equals, plugging in 0, I would get 8, and then 0 to the 5/2 plus c, and then plugging in 0 for t, plus d, and all of that needs to equal my answer, which is 5. The reason that the 0 is so nice to use, right, is because you get to kind of zero things out real fast. 0 times anything is 0, 0 times anything is 0, so we end up with d equals 5. We know our d value now, but that doesn't get us, again, the c that we need. However, we run the same method using the second point here, and we'll be able to get that c value that we're looking for. So when I plug in 1 for t, I want the answer to all of that math to be 10. So I would do x of 1 equals, plugging in 1 everywhere I see a t in this equation, I would get 8 times 1 to the 5/2 plus c times 1. And then we know what d is right now. We just found it out on that last bit. So then I can plug in d as 5. And all of that needs to equal that answer of 10. And now you can see that we're going to be able to very quickly find that missing c value we've wanted this whole time. So we do the algebra here. So 1 to any power is 1. 1 times 8 gets us 8, plus 1 times c gets us c, plus 5, and then all of that has to equal 10. So then bringing the 8 and the 5 together, we get 13 plus c equals 10. And now we're just going to move that 13 over to the other side, and we end up with C equals -3. So now that we have our C value, we can come and plug it into our velocity equation, and we're so close to being done with this. So plugging C into our velocity equation, we would end up with V of t equals 20t to the 3/2, and we know C now. C is -3. And then the last move on this is we'll go find what's happening at the specific value they wanted. So we just need to take 0 and plug it into this equation. So V of 0 would be 20, 0 to the 3/2 minus 3. 0 times anything is 0, so we would end up getting out that V of 0 equals -3. And that would be our option C here. So sometimes, you just got to start working backwards, with the idea that it's like, okay, I know if I can get to the position function, I'm going to be able to find some information out there. And ideally, I can take that information back to get the velocity equation that I want. So work your physics stuff up and down. It's always important to know both directions. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.